Hello grade 12s, welcome to the second video on equations of cubic functions. So as I said, I will call the previous video equations of cubic functions part 1. This is equations of cubic functions part 2. Now it follows on the previous one where it said, what is given? That's always the first question you have to ask. You have to ask yourself, what is the information that they've given you? So in the previous video, we discussed, if they go and they give you all of the x-intercepts, what do you do? This particular video, they say, what if they give you all of the turning points of the graph? So if they're giving you all of the turning points of the graph, in this case, there'll be 2 turning points. You're going to use this particular version normally. And the reason you normally use this particular version, we did discuss it in the previous video, is the coefficient of x cubed. So that coefficient of x cubed, that's given to you. Okay, so coefficient of x cubed, that will be given to you. And that is why we generally then say a is going to be the coefficient of x squared, b is going to be the coefficient of x, and c is going to be your constant value. Like I said, that's just specifically dealing with these particular examples. Now again, I've written it down step by step by step, and we'll refer back to the steps when you do the examples. I'm going to do quite a few examples in this one. I'm not going to talk as much about all the background information as in the previous one. So let's get straight to the steps. Now the first step, if you're trying to get the equation of a cubic function and you know what all of the turning points are. Step 1, determine the derivative. Now you look at that and you go like, how am I supposed to determine the derivative if I do not know the equation? You will determine the derivative in terms of that a value, in terms of that b value, and very important, when you determine the derivative, that constant, that c value, is going to be equal to 0. So technically speaking, what will then happen if you go and you work out the derivative of this fx is you will have the derivative in terms of a and b, but the c value, that will fall away because it's a constant. Then what you're going to have to do is you're going to have to substitute the x coordinates of the turning points into the derivative. And when you substitute those x coordinates of the turning point into the derivative, you have to set the equation that is created equal to 0. And logically speaking, that has to do with whenever we're calculating turning points, so turning points and stationary points, the derivative is equal to 0. So that is why you're going to substitute the x coordinates of the turning points into the derivative, and you're going to set it equal to 0 because at those x coordinates, the gradient, the first derivative, is 0. Okay, so we'll get to that. Then what happens is you will get 2 equations over here. And the reason you'll get 2 equations over here is because they've given you both turning points. So because they've given you both turning points, this step has to be done twice. Once for the first turning point and then a second time for the second turning point. So you'll have 2 equations. Now those 2 equations will both contain a and b, which means they will have to be solved simultaneously. And then once you've solved them simultaneously, you will only need to get the c value, because obviously you will solve simultaneously to get the a and the b value, and then you still need the c value. Now a lot of the time they're very nice about that c value. They give you the y-intercept. Now we've spoken about this before. The constant term in any polynomial function, so whether it's a parabola or whether it's this cubic function, that constant value always represents my y-intercept. And because it represents my y-intercept, I can then just substitute the y-intercept into the c value. Now again, step 5 hardly ever happens, but if they do not give you the y-intercept, they will give you some other point on the graph. So I am going to do an example where they don't give you the y-intercept, and we do have to substitute that other point into x and y or fx to determine the c value. So let's get straight in with the examples. I will refer back to these steps again and again. So the first example in the textbook is page 223, example 2. And it reads, fx is equal to x cubed plus ax squared plus bx plus c. So please note they've given you the coefficient of x cubed. Again, like the example in the previous video, the coefficient of x cubed is equal to 1. So that's been given. Now they've given you both turning points. The first turning point is the point A, which is given as -2, 0. And the second turning point is the point B, which is also my y-intercept. And I know it's my y-intercept because it's got the coordinates 0, -4. And the question just goes, calculate the values of A, B, and C. So in order to do that, we're going to follow the steps. Step 1, as I stated, is determine the derivative. So there we go. Step 1, determining the derivative. First derivative of fx is equal to 3x squared. And this is the part we have to determine the derivative in terms of a and in terms of b. So we're going to say 2 times a, which is 2a, b, and then we're going to make that exponent 1 less. Oh, sorry. Whoa, that was a massive mistake. My apologies. My brain just literally switched off there for a second. Yes, Jared, I know. I apologize. Okay, so apologies about that. Let's try that again. So working out the derivative of that ax squared, we're going to go 2 times a, which is 2a, x to the power of 2 minus 1, which is 1. Now, obviously, you don't have to write the 1, but I'm just showing you how to do this. And then we're going to go and we're going to find the derivative of bx, which is then just going to be b. And please remember the derivative of a constant, because c represents a constant value. And I know it's a constant value because it doesn't have x, that independent variable next to it. So that's why the derivative of c is just 0. So now I've got the derivative in terms of a and b. That was step 1. And now, very important, substitute the x coordinates of the two turning points into the derivative and set it equal to 0. Because again, like I said, the derivative gives you the gradient, and the gradient at the turning points is equal to 0. So I'm going to do that twice because I've got 2 turning points that have been given. So the first one I'm going to do is I'm going to say the first derivative of negative 2 is equal to 0. And then secondly, the first derivative of 0 is equal to 0. And that's specifically because I've gone and I've substituted the x coordinates here of point A into the first derivative. Sorry, that got a bit messy. And I've substituted the x coordinate of b into that first derivative. And I've set it equal to 0. Specifically, the reason why I set it equal to 0 is because the gradient at those turning points is equal to 0. So looking at this first derivative, I then say 3 times negative 2 squared plus 2a times negative 2 plus b is equal to 0. And I'll simplify that just now. And over there, I'm going to say 3 times 0 squared plus 2a times 0 plus b is equal to 0. So there are my 2 simultaneous equations that I will now have to go and solve. So I'm just going to make it slightly simpler here. And I'm going to say negative 2 squared is 4, 3 times 4 is 12, and then 2 times negative 2 is negative 4a plus b, which is equal to 0. Then same thing over here, 3 times 0 is obviously 0, 2a times 0 is obviously 0, so very easy, b is equal to 0. So this isn't actually even a proper simultaneous equation, because I can then just go and I can substitute that b equal to 0 in there. And I can say 12 minus 4a plus 0 is then equal to 0, which means 12 is equal to 4a, and a is then equal to 3. So I've now determined the values of a and b. A is equal to 3, b is equal to 0. And like I said, the c value is pretty simple and straightforward. If they give you the y-intercept, which in this case they have, I'm just going to go and say my c value is then equal to that negative 4. Which means I've answered my question. A is 3, b is 0, c is negative 4. Now, obviously, they like giving these follow-up questions, and the first follow-up question that they give me here is they ask, determine the equation of the tangent to the graph at x equal to negative 1. So if I want to determine the equation of the tangent where x is equal to negative 1, I then first need to write down this equation that I've just determined. And this equation that I've just determined is then f of x is equal to x cubed, which was given, plus ax, and we said a is equal to 3, so plus 3x squared. B is equal to 0, so because b is equal to 0, and that's the coefficient of x, I'm not going to write down x at all. And then finally, c is equal to negative 4, so that's negative 4. So this is the equation of this particular cubic graph. Now, if I want to determine the equation of the tangent to the graph, we're going to follow the steps again. First things first, I'm going to find the first derivative over here, because I'm going to need that, which is then going to be 3x squared plus 6x, and then the derivative of a constant is 0. Then I'm going to substitute that x equal to negative 1, which is my point of contact, into the first derivative. And please remember, I do that in order to get the gradient of the tangent, because substituting into first derivatives always gives me gradients. So that's going to be 3 times negative 1 squared plus 6 times negative 1. There we go. So this is going to be 3 times positive 1, because if you square a negative, it always becomes positive. So it's 3 minus 6, and 3 minus 6 is negative 3. So that's the gradient of the tangent. Then I still need to substitute that x equal to negative 1 into fx to get the y coordinate. So the y coordinate is going to be the f of negative 1, which is going to give me negative 1 cubed plus 3 times negative 1 squared minus 4. So I've got minus 1. Let's write this down. And then obviously negative 1 squared is positive 1. 3 times 1 is going to be 3 minus 4. And this is going to give me minus 5 plus 3, which is negative 2. So the point of contact is the point negative 1, negative 2. So now I have all the information I need to find the equation of that tangent, which is a straight line. So it's y minus 2, which is then plus 2, is equal to the gradient negative 3 times x minus 1, which is then plus 1. And I can just simplify that. So I've got minus 3x, and there I've got minus 3 minus 2, which is minus 5. So this is then the equation of the tangent to the curve where x is equal to negative 1. So that was example 2. Now we're going to do some more examples just because we do have time, and also because according to the Joshua method, they can always go and they can complicate matters. So let's look at first just again a simple straightforward example, except for one little change. The y-intercept, as you notice, is not given. And because the y-intercept is not given, we're going to have to go and we're going to have to calculate that c value. As I stated in step 5, we have to substitute the other point into x and y to determine the c value. So we're going to practice one of these in this particular one. Okay, so this is exercise 9.3 on page 224, number 1. They've given me this y is equal to minus x cubed plus ax squared plus bx plus c. They've given both of the turning points. The one turning point is minus 1, 0, and the second turning point is 1, 4. So following the steps, first step, we need to work out the derivative. So dy over dx is equal to minus 3x squared plus 2ax plus b, and again the derivative of a constant is 0. So I've got the derivative in terms of a and b. Now we're going to go and we're going to set my gradient equal to 0, and we're going to substitute into these x values those x coordinates of the turning points. So that's minus 3 times minus 1 squared plus 2a times minus 1 plus b. That's the first one. And then the second one, again, I'm going to make the gradient 0 because remember at the turning points, the gradient, the derivative is equal to 0. So I know the gradient is 0, and I know that happens at the turning point where x is equal to 1. So I substitute 1 into these x values. So that's minus 3 times 1 squared plus 2a times 1 plus b. So there are my two equations that I now have to go and solve simultaneously to get the a and the b value. So I'm going to simplify this one first, and I'm going to say 0 is equal to minus 3 times positive 1, so it's negative 3, minus 2a plus b. And then this one, 0 is equal to minus 3 plus 2a plus b. Now you could actually go and just take one of these two. So I'm going to take this one and I'm going to say that b is equal to 2a plus 3. So just this one, I'm going to simplify and I'm going to sub that into the b value there. So that's what I mean with solving it simultaneously. You could have also gotten b on its own there and then just set the two equations equal, but either setting the two equations equal or solving them simultaneously, same principle. So over there, I'm going to go 0 is equal to minus 3 plus 2a, and then we said b is equal to 2a plus 3. So b gets substituted with 2a plus 3. And then I end up over here with minus 3 plus 3, which is 0. And then I've got 2a plus 2a, which is 4. So, hey, look at that. A is equal to 0. But now I need to go and substitute this value back to get the b value. So I can then go and I can say, right, so a is equal to 0. 2 times 0 plus 3 is equal to b, which means b is equal to 3. So that's my b value. Now I need to still work out the c value. And in order to work out the c value, this is then the part where we have to go and substitute this a and b value back into the original equation. So please remember, into the original equation. So I'm going to say, therefore, currently, y is then equal to x minus x cubed, as was given, Now plus ax squared, but because a is 0, I do not write the x squared. Then plus 3 times x, because that's my b value, plus c. So you'll notice I just have that one missing value. Now in order to find that one missing value, I'm now going to go and I'm going to substitute any of the 2 points. So any of these 2 turning points in there. So I'm going to go and I'm going to say the easiest one is probably going to be the -1, 0. So y is equal to 0 if and only if x is equal to -1. So I substitute the -1 into x. Now please do not get confused. The reason there's a 0 there is because the y coordinate is 0. The reason here is 0 is because the gradient at those points is equal to 0. So please don't think I'm doing the same thing here. I'm specifically here referring to the fact that the coordinates of the points I'm subbing in is -1, 0. So y is 0 if x is -1. So now what I can do is I can just simplify and I can say -1 cubed, careful, is -1. So a negative times a negative is +1, -3 plus c. So finally, with just enough space, I can go and I can say c is equal to 1 minus 3, which is -2, but then obviously I need to transpose, which means it's equal to +2. And you can look at the graph and you can say, does it make sense that I have that +2 value, which is my y-intercept? Yes, it does look correct. So this is then, as requested, the a value of 0, the b value of 3, and the c value of 2. So I have answered my question, determine the values of a, b, and c. Right, we're going to do another example out of this exercise. And this one again has a little trick to it. So I've just printed it out from the textbook, and this is number 4 of that exercise 9.3. It gives us the graph of the function fx is equal to ax cubed plus bx plus c. Now this one is strange, and the reason it's strange is because in all the previous examples, they've given me that a value, or I should rather call it the coefficient of x cubed. Now they were quite nice in the sense that they didn't give me an ax cubed plus a bx squared plus a cx plus a d. They've shown me that the coefficient of x squared is equal to 0. So I can just write it down there. The coefficient of x squared, let's just write it there, coefficient of x squared is equal to 0. That's going to be important later on, just so I don't try and get a value that's already been given. Because like I said, there's no x squared there, which means the coefficient of x squared is 0. Now they have again told me it has a turning point at -1, 0, and it cuts the y-axis at -2. And then here is something I discussed in the previous video that you have to be very, 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 very careful of. They use the following words: show that a is 1, b is equal to -3, and c is equal to -2. Now that word show that in mathematics can be substituted with prove that. Now in mathematics it's a very, very important rule. Whatever you're trying to show or whatever you're trying to prove, 2 things. First thing, it is true. They cannot use the word show that or prove that unless this is the truth. So if you find other answers than this, it's because you're wrong. You've got to find this because these are in fact the accurate answers. Otherwise they can't use the words show that or prove that. That's the first thing. Second thing, very important, you cannot use these values. So you're not allowed to go and say, oh, c is equal to -2, so I can then just go and I can use it whichever way I want. No, you've still got to follow the steps that I showed you. Now, specifically in this one, you need to notice that they've given you the fact that it cuts the y-axis at -2. So because they've given you the fact that it cuts the y-axis at -2, we are not actually using this value, we're using this value. So we're going to start off by saying for A, the y-intercept of this particular graph is the point 0, -2. Therefore, C is equal to -2. So I'm not using this, I'm using the information on the graph. And that's what I mean with don't use these given values, use the information on the graph. Now I started there, and the reason I started there is you might have noticed I said they have to give you both turning points normally. They didn't give me both turning points. They've only given me the one turning point. So that means I need to go and I need to first find that particular C value. Otherwise, I'm going to get stuck later on. Right. Now, the next thing I'm going to do is I'm going to determine the derivative. So I'm going to say the first derivative of fx is then equal to 3ax squared plus b. So please note, I still have two variables that I need to find there. I still need to find the a value and I still need to find the b value, but we'll get to that one just now. Now, we have got one of the turning points. The one of the turning points, x equal to -1. So I'm going to write it down. At x equal to -1, we have a turning point. Now, I want to remind you again, at a turning point, the first derivative is always equal to 0. So that particular step that I showed you in the previous example, we can substitute -1 in there. And if x is equal to -1, I know for a fact that's given as a turning point, so my gradient is equal to 0. So I can then go to this version of the first derivative in terms of a and b, and I can substitute -1 in there. So I can say 3a times -1 squared plus b is then equal to 0. So simplified, this gives me 3a times +1, so 3a plus b is equal to 0. Now, this is why I said this one is the Joshua method, saying, okay, I've got the steps. I know how to follow the steps. What if they change it up? What if they go and they make it slightly more difficult? And the reason this one is slightly more difficult is they've given me only one turning point. So unlike the previous example where we had two turning points to create two equations to solve simultaneously, I only have the one turning point. And this is why you need to understand the following very, very important concept. Not only did they give me a turning point there, they also gave me a coordinate point there. So -1, 0 has got two things. At -1, we have the turning point, so the gradient is 0. But at x equal to -1, the y-coordinate is equal to 0. So what you should hopefully realize there is I can then go and I can do another substitution. But that substitution won't go into the first derivative that deals with gradients. That substitution will go into the original equation that deals with y-coordinates. So I'm saying the y-coordinate is 0, and remember the y-coordinate will be where x is equal to -1. So subbing -1 into the original equation gives me a y-coordinate of 0, which means I can then go and say a times -1 cubed, and again, not the first derivative, the original equation, plus b times -1, and we've calculated the c value, which is -2. And very important, that's why I first went for that c value, so I can use it over here. Otherwise, I've got 3 variables, which is an issue. So I put that -2 in there, and I set it equal to 0. Now again, this 0 is not because of the gradient. This 0 is specifically because it's the y-coordinate of that point. Got it. So please remember this 0 was because it was the gradient at the point, and that's why it was substituted into the first derivative, because first derivative gives me gradient, and this one specifically is substituted into the original equation because that's the y-coordinate. Okay, so let me simplify this. So it's a times -1, which is -a minus b minus 2 is equal to 0. So now I've got my two equations. So there are my two equations. And that is the two equations that I'm going to be solving simultaneously. So in order to solve it simultaneously, I can just go and I can go back to this equation and say, let's write b on its own. So let's say b is then equal to -3a. So that's the value I'm going to be substituting in here. So I'm going to say minus a minus -3a minus 2 is equal to 0, which means minus a plus 3a, which is going to be equal to 2a, is then going to be equal to 2 because I have to transpose. So a is equal to 1. There we go. A is equal to 1. And then I need to go and I need to substitute this value back in there. And I need to say b is then equal to -3 times 1, which means b is then equal to -3. So please note, I haven't actually looked at all at the values they gave me in the original question, which is show that A is 1, B is equal to -3, and C is equal to -2. Because as I explained to you guys, you can't use what you're trying to prove. So only after you've done all of these calculations do you now go back to this to check your answer. So they wanted me to show A is equal to 1, check, A is equal to 1. They wanted me to show B is equal to -3. From my calculations, check, B is equal to -3. And they wanted me to show C is equal to -2, check, C is equal to -2. Again, that -2 doesn't come from this value that they've given me, because I'm not allowed to use that. That comes from the information on the graph. So please, people, there's no other way to do this. You cannot use these values and try and reverse engineer it, meaning assume these values are true, then substitute it in, and then work out the x-intercepts or the turning points and say, look, it's the same, therefore that's the correct equation. That is not allowed. It is not allowed. You will get 0 for it. It's a breakdown. Now, as for the rest of the questions, what we're going to do is we're going to see how far we can get. I might run out of time in the video, but let's see how far we can get. The next one says, calculate the coordinates of the local minimum turning point A. So, for B, we're going to start by saying to calculate turning points, we set the first derivative, and let's just quickly write down the proper equation of fx. Fx is now equal to A, which is 1x cubed, plus B, which is -3x, plus C, which is -2. And like I said, people, if you accidentally got the wrong values over here, if you got a different A, B, and C value than what they asked you to prove, never ever use your incorrect values. Always use the values they give you. Otherwise, the rest of the questions pretty much become impossible to do. So please, people, use the values they've given you. So for turning points, we work out the first derivative, which is then going to be 3x squared minus 3. I set that equal to 0. I factorize, taking 3 out as a common factor. And then I can finish my factorization, x plus 1, x minus 1. And x is equal to -1. Or x is equal to 1. Now, by the way, this obviously we know that is the turning point they've already given me. So this is the turning point for A. So I'm going to continue with this saying I need to get the y coordinate, which means substitute 1 into the original equation to get y coordinates. So it's 1 cubed minus 3 times 1 minus 2. So this is going to be 1 minus 5, which is -4. So A has got the coordinates 1, -4. There we go. Then C, in this particular question, they ask you to determine the, C says calculate the x-intercept at B. Now, to calculate the x-intercepts, we can very easily just go and use the calculator. Or if you really want to, we can go and we can use the factor theorem, but in general, the silver calculator, like I explained, is absolutely fine. So, equation mode number 4, my A value is equal to 1. My B value is 0. Careful, people, don't mess that up. My B value is equal to 0. My C value is equal to -3. And my D value is equal to -2. Which then means I've got an x-intercept at 2, and I've got an x-intercept at -1. I'm not surprised to find that -1, because that is already on the graph. So I know I'm going to go and I'm going to use x equal to 2, which means B is the point 2, 0. So that's pretty easy and straightforward. Okay. Then D. Determine the point of inflection. So remember, point of inflection, second derivative equal to 0. So I find the second derivative by just using that particular first derivative and then finding the derivative of the first derivative. So that's going to be 6x. And I need to set that equal to 0, which, very simple, x is then equal to 0. So if x is equal to 0, I don't actually have to go and work out the y coordinate, and the reason being that I already know that where x is equal to 0, y is equal to -2. So the point of inflection is the point 0, -2. Then E asks, for which values of x will the second derivative be greater than 0? In other words, where is the graph concave up? Because second derivative greater than 0 is concave up. So it's from this point of inflection onward, the graph is concave up. So reading it just off the graph for x greater than 2. Sorry, whoa, that was wrong. For x greater than 0. I've done this multiple times, and you will probably also make this mistake. We have to refer to the x coordinate, not the y coordinate. So for x greater than 0. Then